everyone, in this video we are going to solve for x to show that lines are parallel or prove lines are parallel. So basically for corresponding angles, if the corresponding angles are on those are the ones on the same corner at each intersection, if they're equal or congruent, then the lines are parallel. If alternative interior angles, the angles that are on opposite side of the transversal and inside the parallel lines are equal, then the parallel lines are equal. So let's look at some examples. Here is a simple one. So basically, we have these angles here. 60 is here, so we know alternative angles are equal. So I'm going to put a 60 here. So this is number 1. So that means 6, and these intersecting lines are equal. So we have 60 degrees equals 3x degrees, or 60 equals 3x. Divide both sides by 3, so x equals 20 degrees. All right, so these are in the same corner. These are corresponding angles. They're on the same side, on the same corner. So x here would equal 20. All right. Now this one, let's look at number 2. Number 2 is a little different. We don't have corresponding, we don't have alternate interior angles. But I can make this one 80 degrees. And then I'm just going to use my supplementary angle theorem to know that 80 degrees, 80 plus 2x equals 180 degrees. So I subtract 80 from both sides. That's number 2. And we get 2x equals 100. So x would equal 50 degrees. So this is 50. X equals 50. So this whole angle here, 2 times 50 would be 100 degrees. So this would be 100 degrees. So that means these lines are parallel. Now, both of 3 and 4 are alternate interior angles. So if they equal, then the lines are parallel. So I'm just going to set them equal to each other. So we have x minus 20, this is number 3, equals 70. Add 20 to both sides. So you get x equals 90, or 90 degrees. So x is 90 here. Because if the alternate interior angles are congruent, then the two lines, we'll call them L and M, are parallel. And the same thing happens with number 4. Alternate interior angles, so they should be equal. So you do 3x equals 60. So divide both sides by 3 and you get x equals 20. So if x is 20, then these lines L and M are parallel. Now let's get into some harder ones. We have these two parallel lines. Now it's given that they're parallel. So basically, I know that my alternate interior angle here is 2x minus, it's not 2x, it's 24x. 24x minus 1. And for this one, my alternate interior angle is 20x plus 5. So to solve for x, I'm just going to use my supplementary angle theorem and add these up, because we're not proving that they're parallel. It was already given that. So we have 20x plus 5 plus 24x minus 1 equals 180. That's your supplementary angle theorem. So we have 44x plus 4 equals 180. And you have 44x. Subtract 4 from both sides. That equals 176. Divide both sides by 44. And you get 176 divided by 44. And that gives you 4. So x is 4. Since x is 4, let's figure this out. We have 20 times 4 plus 5 degrees. That's going to equal 80 plus 5 degrees, which is 85 degrees. And let's do the 24 one. So we have 24 times 5, or 4, x is 4, minus 1. That's going to be 86 minus 1 degrees equals 85. So since these are the same, they're the same because these two lines are parallel. Now this one, we're going to do the same thing. We have, what are these called? These would be like 8 and 2. Do we have that? So let's just write this. We're going to make alternate interior angles. So this would be 12x minus 4. So for these two lines, it's given that these two lines are parallel. So this should equal this. Alternate interior angles should be congruent. So we have 12x minus 4 should equal 10x plus 10. So I'm going to subtract 10 from both sides, 10x, and add 4 to both sides. So that's going to give you 2x, that's a 0, equals 0, and that's going to be 14. So x equals 7 when you divide both sides by 2. So let's plug it in. If we have 12 times 7 minus 4 degrees, that should equal 10 times 7 plus 10 degrees. So 12 times 7 is 84 minus 4 is 80. So this is going to be 84 minus 4 degrees equals, and we'll do this one, 70 plus 10 degrees. So that's going to be 80 degrees equals 80 degrees. And now we have the converse of the alternate exterior angle theorem. So it says if two lines are cut by a transversal, I'll call that the transversal, so that the alternate exterior angles, which would be angle 1 and 8 in this example, if they're congruent, then the lines are parallel. So we're going to solve for x and make them congruent so that L and M are parallel. So let's look at that. We want them to be equal or congruent. So we have negative 1 plus 14x equals 12x plus 17. And we're going to solve for x. I'm going to subtract 12x from both sides and add 1 to both sides. So that cancels. You get 2x equals, that is 0, 18. So x equals 9. And when you plug back 9 in to the equation, you get negative 1 plus 14 times 9 degrees. And that's going to be negative 1 plus 14 times 9. I did that wrong. So negative 1 plus 14 times 9. That's going to be 125 degrees. just to make sure we did it right. And let's do this one too. 12 times 9, I'm using substitution, plus 17. That should also equal 125 degrees. So I'm just going to double check. 12 times 9 plus 17 equals 125. So it does work out. And so here is what I just said earlier, if you want to take a look at that. So that's how to prove that lines are parallel. Thank you. Have a nice day. Bye-bye.